Hey guys, in this video I will present you the basic methods of numpy package. First, we need to import numpy as np for shortcuts. So import numpy as np. Now, to check the version of numpy in your computer, you can simply write np.version. Now let's create a simple Python list and convert it into a numpy array. So let's call it my list and equal to 1, 2, 3. And now x equals to np dot array of my list. Now let's just print x and see the results. Okay. Now let's create an array with vectors of 7, 8, 9, and 10, 11, 12. So x will be equal to np dot array of 7, 8, 9, then another vector of 10, 11, 12. Let's print it. Now, to check the dimensions of a numpy array, we write x.shape. And as you can see, the first value is the number of rows, and the second value is the number of columns. Also, you can get the number of rows with the usual len function. Just simply write len and then x, and you get 2. Okay, next we need to create a numpy array that starts at 0 and count up by 2 and stops right before 30. For that, we use the arrange function. So x equal to np dot arrange, and then it starts with 0, ends with 30, and count up by 2. Just print it. Okay. Number 7. Here we need to reshape this array into 3 by 5 array. So x dot reshape, and then the desired shape, which is 3 by 5. Let's just print it. Next, we need to create numpy array that contains 9 evenly spaced values from 0 to 4. So x equal to np dot line space, and then it starts with 0, ends with 4, and we need 9 values. Okay. Number 9. Here we need to create an array of ones with dimensions of 3 by 2. And we do that with np.ones function. So np.ones. And then the desired shape, which is 3 by 2. Let's just print it. Okay. In the same way, we can create an array with 0 values with this function np.zeros, and then the dimension will be 2 by 3. Okay. Now, to create an identity matrix, we use the high function. So np dot I, and then 3 by 3, and we get the identity matrix. Okay. We also can create diagonal matrix with different values than 1 on the diagonal. For example, if y is equal to 2, 3, 4, list of 2, 3, 4, we can create diagonal matrix with y values. So np dot diag of y. Let's just print it. In the same way, we can put the diagonal above the main one by changing the k. So for example, np dot diag and then y, and then k equals to 2, we get this, where the diagonal is right above the main one. Actually 2 diagonals above the main one. Okay, and also we can write negative k, and this will give us the diagonal below the main one. So for example, np dot diag and then y and k equals to -2, for example, will give us the diagonal here below the main one. Okay. Next, we need to repeat this array 3 times. Okay, so we write np dot array and then just this list, and we use the repeat function, and we give the 3 value. Okay. Number 14. Stack the array P vertically with itself multiplied by 2. So we have P, which is just a matrix of 2 by 3 with values of 1s. So np dot vertical stack of P and then 2 multiplied by P will give us this. And for horizontal stacking, we can just write np dot horizontal stack and then again P and P multiplied by 2. Okay. Next, we will see a few operations between arrays. The first one is element-wise addition of 2 arrays. We have x and y, which are numpy arrays. For addition, we simply write x plus y. And as you can see, we get the result as numpy array. For subtraction, we write x minus y. Okay. Element-wise multiplication is x multiplied by y. Element-wise division, x divided by y. Just simple operation. And element-wise power will be x power 2 or np dot power of x by 2. Okay, as you can see, they have the same result.